If you ever had a look on Flight Radar 24, you will surely have noticed that there are a lot of airplanes over Switzerland every single day. But where do they all take off from, and where do they land in Switzerland? Let us find out with a lovely heat map and a BFS dataset. So let's start right off with our dataset, and I have one for you prepared right on my screen. As you can see, it's an Excel sheet called flight data, and data stems from the government, from the BFS. And you can see here we have a lot of different airports here. All the data is coming from 2022. We have different types of airfields. I will come back to it later. We will only look at the total basically movements, or basically there are just takeoff and landings. So we only count them in the year 2022. We have the total number, and here we have the geolocation. So let's go right in our trusty R environment. As you can see, it's empty, and I will show you today how we can actually visualize this data in a very nice heat map. A heat map is basically just a rough indication in which area how much activity is. So for that we need to load the libraries, and as you already know, this is my way of doing it. So here I first type in libraries, so we have a little bit of order in our data, or in our code. And I will show you right now which kind of libraries you need to load. First of all, we need to read the Excel file, so we need read XL. We need also Leaflet, it's called. That's a very cool library, and it's basically the library where we can visualize the data with a heat map. Now we have also library extra, sorry, written wrong. Yeah, Leaflet. So the library is Leaflet extras. And last but not least, DPLYR, which is here for data manipulation. Then we need to do the data input, and you already know it because we already did it in our data set with the blood pressure, and we call it airport data, and it is the function readXL, which is basically a function from the readXL library. And here we need to input our path to the data set, and our data set is located in the folder codes, in the folder airfield, and it's called flight data, as you already seen before, XLSX. So yeah, and let's load data and see if we get a good result. And for that we need to save it. Let's call it airport or airfield. Let's call it airfield. It doesn't matter actually what you call it. Of course, call it something that you can remember. Most of the time I use main, that I know it's my main file. I will put a link down in the bio where you have access to the GitHub repository, and there you can find all the data. I will probably rename the file again, but you can click it and then you have access to all the necessary data. So let's get back to the screen, and here when we run this code, you can see down below in our console that the data was imported. Head is basically a function, and I think I already said that in another video, where you can see the first rows of the data set. Here in this case it's 6 rows, and yeah, you can see there is another function called tails, and it's basically the same thing, but it's the last tail, and it's the last 6 rows in the data set. Here in this one, you can see that in the type, there are different type of airfields. So they have a different size, and you can see it very distinctively in the number of flights per location. What does that mean? So for example, Zurich has over 216,000 flights in the year 2022, which is significantly more than, for example, Sion, which only has 45,000 flights per year. So there is, let's say, a difference between them in flights that is really significant, and we will run into a problem if we show it on a heat map, because if we have such big numbers compared to smaller numbers, then the smaller numbers may likely disappear from the data visualization. You will see it later, I will show you. So let's continue actually with filtering the data based on the sizes of the airfield. That's important, as you just heard, because of the difference in flights per location. So let's call it filter. And what we actually do is we say small airfields, for example, small airfields, and this is airport data. And now we have a special sign, it's this one, which you have to, it's very R specific, and you have to do it because then you can filter something. Of course, there are a lot of other things you can do while using this sign, but one of it is to filter. So we filter airport data, and we filter the column type for one thing. So one characteristic, which is in our case Flugfelder. If we do that, I can show you, can run this code, and then head of, let's say, small airfields, and I run this, then you can see here we only have type Flugfelder left. So this is what we want to do. And here, for example, Dübendorf has 240 flights per year, which is insanely low compared to Zurich. And yeah, so we filter it based on the sizes of the airfield, so that we do not have the huge distance between like a huge airport like Zurich, Basel, Geneva, whatever, and a small airport like Dübendorf that only has like 200 somewhat flights per year, and basically there would be zero color for Dübendorf. You wouldn't even notice it on the map. So this is why we filter it. So then we have the mid airfields, which is basically, we do the same, it's airport data, again with the special sign. We filter it today now based on Regionalflug heaven. And then we have the big airfields. Airport data. We do it like this again. We once again use the filter type. Oh, sorry about that. Did we put here? Oh yeah, we need two equal signs. Sorry about that. And then we have Landesflughafen, which are the big airports. And now we can start building our heat map. It's actually pretty easy. So we take, for example, the small airfields first. And now you can see the advantage of this special percentage file, which is very R specific again. We use Leaflet for it. So basically we have now airport data, we load all the data, we filter it and call it, or we filter it based on Flugfelder, which is then only the small airfields, and we take the small airfields and use Leaflet, the library we put in at the very beginning, and we take Leaflet, again the percentage sign, and then we add tiles, which is actually a way of adding basically a map, and we add over it the heat map function. And of course we need to put in here some specific data in order for it to work. Well, what do we need? You can see here on the yellow card that we need the coordinates, so longitude and latitude, and we also need the value. So these three things, and then we have some characteristics we have to put in and play around a little bit, that the heat map actually looks good, or the heat map looks the way we want to look it, or we want it to look. So let's put in the longitude, which is in our case a special sign, which I have to copy. It's this sign, because I always have a very long time to find it on the keyboard, so I just copy it most of the time. And yeah, basically what we're doing here is we put in the longitude and latitude, or we define what it is. Of course, we have it here in our data set, it's lat and long, or we called it this way, so we put it in this way. And then we add blur. I will show you later what it does. We put in max value and we put in radius. I will later explain what they do actually. And last but not least, intensity, which is basically the value we want, and of course that's flights. Now let's run this code, save it and run this code and see what's happening. So we got our first working heat map, and this is exactly what we wanted. So you can see here, these are just the small airfields in Switzerland where they are located and where the most flights are happening. So you can see that, for example, here over, well, it's Glarus, I think, there's a lot of activity. Let's zoom a little bit in, and then we can see why it's like this, because there are a few airfields, Wangenlachen, Schänis and Mollis, which are really close together, and they have a lot of flights per year, or a lot of takeoff and landings. So they are red basically. So there's a lot of activity going on in this region. And of course there are also other regions, and yeah, just a reminder, these are only small airfields. So we can do that also now with, for example, the mid, or let's take the big airfields and see what's happening. So, genau, we take this, and yeah, this is exactly what I thought will happen. So there are only 3 big airfields in Switzerland. It's Basel, it's Zurich, and it's Geneva, which are from the characteristic Landesflughafen. And yeah, it doesn't say a lot. And now we also take the mid airfields. These are from the characteristic Regionalflughafen, and there are more of them. It's like Bern, Grenchen, and Fribourg, etc. And as you can see, it only makes sense from the perspective of the small airfields, but let's mix together now the mid and small airfields. I think that will make a lot of sense. So let's call it small mid airfields. And yeah, we just use again the exact same syntax as before. We filter it, but this time we filter it with a special sign like this, and we use very R specific again, the C before the brackets. We take Flugfelder and then we add Regionalflughafen, and we replace the mid airfields with the small airfields. And now we should see, I have a typo in the syntax again. Let's see, filter type C. Actually, it looks good. Let's run. There is some sort of error, but I cannot see exactly where. Oh, filter is wrong. Again, a typo. Now it works. And yeah, this one looks actually really beautiful and actually quite useful, because the difference between Regionalflughafen and Flugfelder is not that big in terms of flights per year. So the distance between the values is not that high. And as you can see here on the plot, it actually makes sense. So we can see in which regions there is a lot of activity, in which regions there is not that much of an activity going on. And I think that's a beautiful way to actually visualize activity based on a map or on a map. And yeah, it's super cool. Now, as promised, I want to show you shortly what the values do that are inside the add heatmap function. The blur is basically, let's pump it up to 400 and see what's happening. Oh, that was too high. Let's take 100. And as you can see, it blurs the whole thing. You really need to play around with those 3 characteristics in the function, because it's very much based on the data set you have. A heat map, or this kind of heat map, is not an exact science. It's more of a visualization or a generalization of the data. Same goes actually for the max. So this is the maximum value, and of course also the radius. The radius is basically how far the paint dot is going, if that makes sense. All right, this is actually what I wanted to show you today, and I really hope you enjoyed it. If it was helpful for you, leave a comment down below and press this like button if you stayed for the whole video, if you stayed so long. That's super cool. I hope I could help you guys out, and if you haven't already subscribed to my channel, please do it. It really helps the channel out, and I see you guys in the next video.